Hello students. Today we are going to discuss another question. This is our question 3 in our question video series. Let's look at the question. A statistics student believe that the mean score on the first statistic test is 65. A statistics instructor thinks the mean score is higher than 65. He samples 10 statistics students and obtains the scores. They have given a sample of scores for 10 students like 65, 66, 71, 66, 68 and lastly 71. He performs a hypothesis test using a 5% level of significance. The data are assumed to be from a normally distribution. Okay, when we come to this question, you see a sample of data, right? 65, 66, 71, 66, 68 and so on. Since they have not given you x bar, you have to calculate that one first. So take the sample data. You know how to calculate x bar. It is sigma x divided by n. Add all the values in the sample and divide by number of values. Then sigma x is equal to 675. N is 10. Right? This value is the sigma x value. Sum of all the marks of statistic students. Then x bar is 67.5. Next, you don't see any standard deviation is given, either population or the sample. Since they have given us the sample, we can calculate the sample standard deviation from that one. So, calculate the sample standard deviation. This is the formula for sample standard deviation. So this is how we are going to do that one. Already this came from the first step where we found x bar, right? This is sigma x 675. All other things are meaning of this one is take each data point value and square it and add to the next number squared value. According to this equation, the standard deviation of the sample is 3.3747. So, according to this question, now what we know, n is equal to 10, x bar is equal to 67.5 and s is equal to 3.3747. That's it. Right? Go back to the question. Now decide which distribution to use. We have our sample standard deviation and data distribution is also normal. Sample size is less than 30. For this case, we use students t distribution or the t distribution. We don't know the population standard deviation there. The data are assumed to be form a normal distribution. So we use t distribution. When it comes to the t distribution, you know, we should know something like degrees of freedom, right? So the degrees of freedom is 10 minus 1, which is 9. Okay, now what is the claim here? A statistic instructor thinks the mean score is higher than 65. But you will think that first statement, look at the first sentence in the question. A statistic student believes that the mean score on the first statistics test is 65. Why can't that be the claim? That is not the claim. Why? Because who take the sample? The statistic instructor. Who wants to test that one? The statistic instructor. So the claim goes to that person, right? He wanted to check that. Therefore, he collected a sample of 10 student marks and performed a hypothesis testing. So the claim is a statistic instructor thinks the mean score is higher than 65. So then the population parameter is mu greater than 65. This is the claim. Write down the symbolic opposite of this one. Mu less than or equal to 65. Now we know that the statement with equal mark should goes to the null hypothesis. So our null hypothesis is mu less than or equal to 65 and then the claim is going to be the alternative hypothesis. So mu greater than 65 is the alternative hypothesis. Okay. Same as the C test statistics, we have to calculate the test statistic for this type of question. So instead of z equals x bar minus mu divided by sigma divided by square root of n, instead of here sigma, we know the sample standard deviation. So we replace this sigma with s and change this c with t. That's how this equation is made, right? So substitute the values. X bar, you know, right? 67.5, and mu is coming from the null, right? So null has 65. So substitute 65 to the mu, and S, what we know, and we calculated that one 3.3747, and divide that by number of values in the sample, that is 10. Then the t-test statistic value is 2.343. Next, we are going to take the decision whether to reject null hypothesis or fail to reject null hypothesis. We can have two ways to take this decision. First way is critical value method. The other way is p-value method. Okay, let's move into the critical value method. Since we have greater than mark in our alternative hypothesis, this is a right tail test. So, according to that one, the critical value should be in the right tail. Then we should color the area that is equal to significance level, which is 5% given in the question, that is 0.05, write to some t-value and then find the t-value. So because this is a one tail test, you should first select that one tail row. Okay, you selected that one, and the significance level is 0.05. Then select that column. Okay, this one. Next, take the degrees of freedom and go through that and find what is the value under the one tail 0.05. So that value is 1.833. So our critical value is 1.833. Now look at our test statistic value. It is 2.343. Okay, it's somewhere here, right? It will fall into somewhere here. 2.343. Critical value is 1.833. The area left to that value is the fail to reject H0 region, and area right to that one is reject H0 region. Why the area right to the critical value becomes the reject H0 region? Because this is a right tail test. So according to the test statistic value, it has fallen into the rejection region. So our decision is to reject H0. Okay, critical value method is done. Next, we should look at the p-value method to take the decision. Since our test statistic is 2.343 and this is a right tail test, the p-value is the right side area to the test statistic value. And our degrees of freedom, df, we found 10 minus 1, that is 9, is here. And mark the one tail and go through this 9 degrees of freedom row and find out where 2.343 is. That value is in between 2.262 and 2.821. So for those two values, one tail area is 0.025 and 0.01. Why we took two values here? Because 2.343 is in between 2.262 and 2.821. We discussed these things in our previous videos. So if you don't remember how we got the p-value from t-table, please look at that video. So we take these two values and add those together and divide by 2. Why we divide by 2 is we think that 2.343 is midway between these two values. Okay, that's why we add them and divide by 2. So you will end up with this answer, that is 0.0175. Okay, to take the decision, we compare p-value and the alpha. According to that one, p-value is 0.0175 and alpha is 0.05, right? 0.0175, that is less than alpha. Alpha is 0.05. So the decision according to this one is reject H0. We got the same answer as critical value method. Okay, so according to that one, we can say there is sufficient sample evidence to claim that or think that the mean score is higher than 65. That is the conclusion in this question. So that's it for this question. This was done using the t-distribution, and hope you all understood the question very clearly. Go through the question many times as you need and practice well. Thank you, and let's meet with another video.